Hi ladies, in this video we're going to go through 6F, which is scientific notation. So it's put here in indices because we tend to write scientific notation using indices. We use them for very, very, very big numbers or very, very, very small numbers. So for example, here we have the number 38 million. So writing that if we had to write a lot of numbers that were in their millions, it would take up a lot of space, so we tend to just write it in index form. So 38 million is the same as 3.8 times 10 to the power of 7. So to do that, and we'll do a few examples in a second, we just look at what numbers we have at the start that aren't 0. So we've got a 3 and an 8. So you always write the first number as a single digit, so 3 and then decimal and then whatever numbers are after that, and then times to the power of how many spaces you have after that decimal point. So you can count them up. So we've got, starting at the 8, so we've got 1, 2, 3, 4, 5, 6, 7. So that's why it's 10 to the power of 7. Very small numbers, we use negative powers, okay? So if we're looking at 417 nanoseconds, you can see here at 0.0000417. But same thing, we take but we use the numbers at the end this time as opposed to at the beginning with 38 million, and we write it as 4.17, so everything other than the zeros, and then we count up how many decimal places we have after the decimal point. So we've got 1, 2, 3, 4, 5, 6, 7, and then we have our decimal point, or how many places your decimal point has moved. All right, so there's some examples there, which might be helpful to have, but let's do some questions. So for this one, you only had to do questions 1 to 6. So let's have a look at question 1A to begin with. So we've got 43,000. So we write whatever digits we have at the start, excluding the zeros that follow. So it's just 4.3. And then if you want, we can count up like this, 1, 2, 3, 4. So the decimal places moved 4 spots. We write it as 4 times 10 to the power of 4, and that's a 4. Sorry, it's just a messy 4. Part 2, we have, I don't even know what this number is. How many zeros do we have? I think they're in groups of 3. So 3, 6, 7. Okay, so we've got right as 1.49, and then how many places our decimal spot has moved. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be times 10 to the power of 9. Now, when you've got really small numbers, like we do in B, we've got 0.004. Just going to give myself a bit more space. So we write the 4. Now, sometimes you would see 0.0, but we're just going to leave it as 4, and then times 10. Now, because we're moving the decimal place in, I guess, this direction, 1, 2, 3, it's going to be -3. Okay, because when you think about this 4, that's the same as 4 thousandths. Okay, which is a very small number. And that -3 is 10 to the -3 is the same as 1 over 1,000. So that's, yeah, the proof behind that. Okay, so part 2, how many zeros have we got? 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 1. So we write the 6.1. So the decimal is in between here. Count up how many spots you've moved. 1, 2, 3, 4, 5, 6. So it's times 10 to the power of -6. So question 2, quite similar. You should know hundreds, millions, thousands. So hundreds, you're just adding on 2 zeros to that number. Million, you're adding on 6 zeros. Thousands, you're adding on 3 zeros. Question 3 is quite similar to what we've done. Just, I might do 3G with you because I wanted to do a question where there was a 0 in between. So 3G, We've got -0. Now it's going to be hard to work out how many zeros we've got. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 809. So your decimal place is here. Now we do write 8.09. Now I wanted to make a point here that even though I said you don't include your zeros, you do if they're between other numbers, okay? But not if they're a leading zero or a zero at the end. But if they're between, we do include the zeros. All right, so then it's times 10 to the negative. So we've got moved 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of -9. All right, just moving down to question 5. So this time you have to write it, you have to do the opposite basically, writing it in decimal form. Oops, I'm just trying to get rid of all this. Start fresh. Okay, so let's do 5G. So we've got 1.97 times 10 to the power of 8. So this means when we write it, we move the decimal place 8 spots. So if I write 197, I've already moved it twice, and I've got 6 more to go. So I just add 6 zeros. So 1, 2, 3, 4, 5, 6. And if you want to check that we've got enough zeros, just count how many spots your decimal has moved. So at the moment it's here. So it's gone 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the same for the negative. So if we look at question 6, and let's do, let's do D. 3.52 times 10 to the -5. So we're going to have, if you wanted to, you can write the numbers on the end first. So 352. Now it's already moved 1 spot to get to there. So we're just going to move it another 4. So add your 4 zeros. So it's moved 1, 2, 3, 4. Whoops, sorry, 5. I was getting distracted. I really thought Word was going to shut down on me because a little thing was coming up. Okay, so we'll just get rid of that. Okay, so let's just double check that that's right because I felt like I got a little bit distracted. 1, 2, 3, 4, 5. Good. Okay, so you got your decimal point there. All right, girls, scientific notation, it's something that you will see. Sometimes your calculator puts answers in scientific notation, but they use an E instead of 10. So you just need to be aware also that that could happen. All right, bye, girls.